Oops. Sorry, I had it at the end of the file. We're on lesson 25 on the biblical flood, and we're going to be looking into chapter 9, I believe it is. Most flood models do not adequately explain glaciers and the ice caps. They don't explain them. And in fact, this was what steered a lot of people away from believing in the flood. And until the 19th century, the geologic establishment generally believed there was a worldwide flood. That was pretty general. But in the 19th century, by the 1800s, something happened. I had this locked up on me. This changed with the discovery of gravel called till, T-I-L-L, that was related to glaciers, and they called it glacial till. The early flood advocates did not believe that the ice caps or glaciers were in any way linked with these gravels called glacial till, and they called them superficial gravels at that time. And the early flood models did not explain the existence of the ice caps in Greenland and in Antarctica, particularly those two places. Okay. We're going to consider glaciers, begin a consideration of it. We're just kind of touching the surface a bit. We'll have several lessons on this, their origin and their effects, how they came about, and we'll explain them with our flood model in accordance with the flood model we're developing. Gould, this is Stephen J. Gould, an atheist. I think he's dead now. I think he died. But Stephen J. Gould, flood geology was considered and tested by early 19th century geologists. They never believed that a single flood had produced all fossil-bearing strata, but they did accept and then disprove a claim that the uttermost strata contained evidence for a single catastrophic worldwide inundation. So they supposedly disproved it. The science of geology arose in nations that were glaciated during the great ice ages, and glacial deposits are similar to the products of floods. Well, he's right with that. There are some similarities. During the 1820s, British geologists carried out an extensive empirical program to test whether these deposits represented the action of a single flood. He goes on and says, fieldwork proved that the superficial gravels were not contemporaneous, but represented several different events, multiple ice ages, as we now know. And my flood model will explain that. Geology proclaimed no worldwide flood, but rather a long sequence of local events. In other words, he is actually arguing for uniformitarianism. No, but rather a long sequence of local events. He's rejected catastrophism. Notice he didn't have any idea of catastrophes involved in any way. So his whole system then dealt, and he runs back to uniformitarianism right here. It's what he does. Right? I don't think he's a geologist. I think he was a biologist. Okay. Geology revealed that dramatic changes, this is Smith, and again, you've got the book, so you can get the references, revealed that dramatic changes have occurred in the Earth's flora and fauna. Flora would be plants and fauna would be animals. And remarkable fluctuations in Earth's climates were also discovered. Now, my flood model will explain these fluctuations. In particular, it became clear that recently there had been a glacial period in which large portions of the Earth's surface have been shrouded by ice sheets, such as those that today survive on in Antarctica and Greenland. The glacial theory began to be developed during the 1820s in Switzerland. Okay. One of my great grandmothers was Swiss, full-blood Swiss, and her husband was a full-blood German. Okay, so I guess I'm 1/8 Swiss and 1/8 German. In 1836, the idea was taken up by Louis John Rudolph Lagasse. He died in 1873. And in the following year, he began to use the term Ice Age and to voice the somewhat exaggerated view that the whole of Europe was as far south as the Mediterranean had recently been engulfed by ice flowing southwards from the North Pole. To many, this idea of glacial deluge seemed dangerously like a reversion to catastrophism. Catastrophism would be the idea that there was a flood. Notice they rejected it because it sounded too much like the Bible, the idea that the flood occurred. Okay. Again, we see bias on their part. It seems that anything that's linked to the Bible is rejected by the atheists without even giving it consideration. Again, that's not very honorable and as far as being seekers of truth. In this series of studies, we will give evidence of bias by some scientists against anything that might be interpreted as theistic. We're going to give other evidence of their bias, so they're biased. A true scientist follows the evidence, and when they let their bias cause them to ignore various principles, various facts, then they're not real scientists. Okay? I don't care how many degrees they have, they're not scientists. These ice caps have subtropical plants and animals entrapped within the ice. That is very interesting. Something happened. Subtropical plants then were engulfed in the ice. So this ice had to occur very rapidly in order to do that. The plants are dated in the Eocene period by geologists. Of course, this is based on atheistic assumptions, uniformitarian geology. But we'll just go along with their Eocene period and use it. Supposedly, it went from about 34 million years ago to about 56 million years ago. So that Eocene period supposedly went for that time. Francis, and this is the man's surname, the fossil flora and fauna of the Eocene Arctic reveal a warm, swampy, subtropical environment similar to that of Florida, of the Florida Everglades. That's telling you something. This is the Arctic regions. That would be up in Greenland, northern Canada, and Russia. The atheists claim that the Arctic region was essentially the same location that it is in presently. And we're going to give a map of the globe according to the atheists, what they claim it looked like in the Eocene period. And so let's look at it. You notice here's the United States, here's South America, Africa, and there's, I guess, Australia, and there's Antarctica. This is part of Asia. All right, there's Greenland. But they're saying that this Arctic region, that'd be northern Russia and Greenland and northern Canada, Alaska included, that region is basically in pretty much the same place it was located during the Eocene, according to their map. This is a map that I pulled off the internet, off a website. Okay? And I've looked at other maps, and they claim that they're the same thing. Okay? All right, this supposedly moved northward and bumped into this subcontinent. This was part of India, and now it's part of India. That's what they claim. Now, when we go back, we can find mammoth, woolly mammoth tissue, and they have done histology on it. They've done a study of it, the tissue. Basically, it's like CSI. They've gone through and figured out why it died and what its characteristics were. The routine histology of the sections thus confirmed our initial observation that the fragment had all the appearance of a fresh bone. As a further check on the condition of the mammoth bone, we analyzed the bone for total nitrogen and acid extractable carbonate. It's Ezra and Cook. So this was a mammoth bone. The mean value for nitrogen by the Kjeldahl method was 4.2% by weight. For the carbonate, 3.4% carbon dioxide. These values fall definitely within the range to be expected in fresh, compact mammalian bone. So this bone is fresh mammalian bone. It fits all of the histology shows that it's like a bone. So the bone was frozen and it was locked into that state. It's evident that these animals did not die of natural causes. How do I know that? Well, food is in their mouths and in their stomachs. Now, when you get sick, what you do is you don't eat. If you're real sick, your body just doesn't eat. Now, we'll get back to that in just a minute. Hapgood records this, and other sources can be cited. The remains of plants in the mammoth's mouth between its teeth were the same as the stomach contents that represented food the mammoth had not yet swallowed when it was killed. So it had food in its mouth, it was eating, and then it died very suddenly. So we have very sudden death when they're in the process of eating, then they die. We have what's called the sympathetic nervous system, and I believe God created us with it. This sympathetic nervous system, then what it does, whenever you get sick, it shuts down non-essential parts of the body when the animal is ill or when it's sick. Why? It shuts these down because they take energy away that the animal or the human or the animal needs to fight these illness. And so one of the first things that goes away is our desire and ability to reproduce. Reproduction, digestion of food goes away pretty quickly. Desire for food and water go away when the animal's ill, when a human is ill. Okay, so what we have here is the sympathetic nervous system then does this to our body. But these animals had food in their mouths, therefore they were not ill. They didn't die of sickness or illness because the sympathetic nervous system would have caused them not to eat. In Antarctica, on the eastern part of the continent, the ice sits 3 miles thick on the solid ground, Trefl tells us. That's about 15,000 feet or nearly 20,000 feet. The polar ice caps in both Antarctica and Greenland are over 12,000 feet thick in some places. This is from other sources. Now, the weight of this ice causes these areas to sink into the magma. Now, let me lay out something for you. You can put a board just into your bathtub, like a piece of a 2x4 of some kind of wood, and then you put that in, and you can see it'll sink a certain amount into the water. But if you put some added weight on top of it, it'll sink deeper into the water. Now, what'll happen is it will reach a point of isostasy. And isostasy is from isos, which is the Greek word for same, isos, and then stasis, which is to stand. And so what happens is, due to the weight of that you put on a piece of wood that's floating in water, it will sink deeper into the water. Added weight, it'll sink deeper. If you add enough weight, you can immerse the board and make it sink to the bottom if you put enough weight on top of it. So it'll sink to the bottom of the water. It can be made to sink all the way down. The weight of the ice caused these areas to sink into the magma. So the earth, the land, like Greenland, sank down when the ice went on top of it, sank down into the magma of the earth. Now, it's like hydraulic brakes on a car. When you apply a force anywhere, that will apply an equal force everywhere else inside that area that holds the liquid. And think of the magma like a liquid. And so what happens is, if you cause Greenland to sink, it'll cause other parts of the ocean to rise. And so it causes a rising of it. And so the land elsewhere will rise, right? So we see a rising of it. The temperature of the ice has been measured at below minus 100 degrees Fahrenheit or minus 73 degrees Celsius. That's awfully cold, right? Ice has been so cold that the permafrost, that's permanently frozen ground, extends to depths of at least 2,000 feet or 610 meters in some locations. That's been documented. They bored it out and drilled in it. Stokes tells us that permafrost forms whenever the temperature remains below 0 degrees Celsius. That's 32 degrees Fahrenheit. That's the freezing point of water for a period of at least several years. A layer of permafrost from less than 1 meter to about 600 meters. Now, a meter is a little more than a yard, about 39.37 inches. And so that's 600 meters multiplied by 3 and add a little bit. You'll have nearly 2,000 feet. That's what that is. Thick underlies at least 27% of the total land area of the Earth. So we have permafrost at least 1 meter up to close to 600 meters thick, underlies at least 27% of the land area on the Earth. In the northern hemisphere, about 7.6 million square kilometers, 2.9 million square miles, that's my calculation, were underlain by permafrost, according to Stokes. That's a bunch of area, permanently frozen ground underneath the ice. Right? That ice had to be extremely cold to do that. Now, in Antarctica, fossil plants found by Chilean scientists on King George Island put Antarctica's ancient past in the temperate zone. What does that mean? Well, here in the United States, a good portion of the United States is what's called the temperate climate or temperate zone. Further proof of the continent's warm ancestry lies in the cold. It's cold. The transformed remains of forest long dead. I know we've already talked about how cold can be formed very quickly. It doesn't take millions of years. Several grades of fossil fuel exist. Kind of keep that in mind. Other questions or comments? I know I'm reading a bunch, but 5 geologists last year, Tyree tells us, drilled and blasted 20 feet to bring out virtually unweathered Antarctic coal. Widespread discoveries of surface coal and petrified wood show that Antarctica had luxuriant vegetation 10 or 50 million years or more ago. Again, they're dating this by uniformitarian geology. Okay, so I'm not worried about the dating. Okay, since ice has a tendency to insulate against further temperature changes. Now, just think of the Inuits, the Eskimos, we call them, making houses out of wood, out of ice, igloos. And as long as they don't get below above freezing, the ice will stay there, and it's a good insulator. Okay, since the ice has a tendency to insulate against further temperature changes, it's evident the ice was extremely cold at some time in order to cause 2,000 feet or 610 meters of permafrost. And so you got to have an awfully cold ice to freeze the ground down to 2,000 feet down. The weight of the ice produced the cold, no doubt. That's my claim. That ice, that added weight on top of it. They found railroad bridges where they had wooden beams and supported by them, wooden pillars. And the wood, due to the weight of just the trains running over the track, had turned into coal. That's been documented. They have to replace those because it's coal and it doesn't work as well. It won't support the train anymore. The weight of the ice, no doubt, produced coal by pressure. We have another situation that occurs, and we have this, and the atheist has no explanation for it. On the continental shelves, we have canyons out here. Now, canyons, whenever this is covered with water, won't be formed. So the water then, I believe, after the flood, and I believe that we had melting ice as well. We'll get back to it later. But what we have here is we form a canyon that goes out like this. So we have continental shelves. The continental shelves go out, and then canyons are formed. And then there's an area where this sediment ran down onto the continental shelf below. The deep sea fan, they call it fanned out. And we're going to look at some of those, and they look a lot like this. They're called submarine canyons. Continental shelf here, and then it goes down the hill, and then there's a continental rise. And so this is what they call a deep sea fan. Now here's a map of the Atlantic ocean floor. Here's Hudson's Bay. It's not very deep. And what happens here is this ice, as it melts up here, what happens when the ice melts, Greenland rises. It's like if you had put ice on top of a board that's floating in water and the ice melted, the board would rise up out of the water. So that's what happens here. Now, right here, if you look, we see the St. Lawrence Seaway. There's a canyon right here. And right up here in New York, there's a Hudson River Canyon. There's another canyon right here. There's canyons coming out. And right here's one for the Mississippi River going out. So there's a number of canyons that go out from the land. We're going to show some more of these. This is the floor of the ocean, map of it. And so it's pretty shallow right here, out in here for a ways, then it drops off. Now, I'm claiming, and I think the evidence shows it, that this right here at some time in the past didn't have water on it, and that Florida was quite a lot bigger than it is now, okay, because of that. We'll come back to it a little bit later. All right, any questions? All right. So we'll see some of these in larger size. All right. There is a gap between Greenland and Canada across here. And we'll come back to this right in here, a place where water can flow out. Notice right here is pretty shallow, and then it gets deep right here. So water can flow through this. Cold water would flow underneath, it's more dense. And the warm water from the Gulf Stream would flow up and go over. And it comes down and warms the western side of Europe. Look at where London, England is right here. It's the same latitude as the Hudson's Bay, southern part of Hudson's Bay. That's very interesting. It's way far north, but yet it doesn't get as cold. It's more like the Midwest of the United States as far as climate's concerned. It doesn't get that cold. Very interesting. Again, that's the Gulf Stream. Here's some of your Atlantic Coast submarine canyons and seamounts. We'll come back to them later. And so right here's a canyon coming out. That's out of New York, and that's Hudson River, the Hudson Canyon. It's a pretty deep canyon. We're going to come back to that a little bit later with some more information. Right here now, there's Delaware, and comes up, and there's Maryland and Virginia. So right here we have a canyon here, and on here you can see that one pretty prominent. But we have some other canyons from other flows of water. They're not as prominent. Okay? So here's some major canyons. They're yellow as they're laid out. There's your Hudson Valley Shelf coming out of New Jersey and Long Island. It cuts pretty deep down through here. There's some pretty good flow of water at one time. It cut that canyon. And large flow of water can cut a canyon in just a few days. Here's some other canyons, and this is Hudson Canyon right here. Some other canyons up here too. There's not much of a river to form these, to feed them. And I believe there was a river at one time, but it melted. The ice melted. We'll come back to it later. Here's the American shelf, and that's the Armorican shelf, not American. This is the Celtic Sea, and this is Ireland and England across here. So what we have here is, this is pretty shallow, reasonably shallow. I'm not saying it's real shallow, it may be 200 or 300 feet deep, but then it drops off around here and just goes way down, thousands of feet down. There's canyons along here, and I think this was called Doggerland all around England was, the North Sea was dry ground. There's evidence of it. And so we have these canyons that are formed along this. If this was dry ground, then it would form a canyon when it went off the edge of this. So it actually goes off this deep drop. Here's the Pacific Ocean. The Atlantic Ocean is a drop in the bucket compared to the Pacific. Pacific's way bigger. And so right here, we have all of this. This is the Hawaiian Islands. They're formed by volcanoes. We're going to come back and show some reason for seamounts, which we have all across in here. It would explain them with our model. I believe that this was dry ground right in here, and New Guinea and Australia were connected, as well as Tasmania was connected with them. And I believe even the atheists agree with that. Okay. So while here we have along the Yellow Sea and all was dry ground at one time, and the water has risen as the ice has melted. I believe we're having continuous ice melt since the flood, and I'm not worried about it. It's just something that's going to keep happening as long as the world lasts. Okay. So now here's the west coast of South America, Central America, and the United States, North America, Canada up here, and Alaska, Russia over here, Japan, Korea, China, Indonesia, and Australia, and New Zealand. Any questions? You see all of these regions right here. This stuff, I believe it's part of the created by the flood. Okay, our model that we've developed. Here's Monterey, California, undersea canyon. You can see the canyon as it goes down through here, and it cuts through, it goes around, down, cuts down through the ground, cuts through this. And right in here is places where the water ran off. Okay. So the canyon, there's your Monterey Canyon again. That's shown in a little bit different form. The river comes down through here. Now then, this river right here doesn't have enough water to cut a canyon that big very quickly. But if we had a lot more water flowing off right at the end of the flood, it could cut that canyon very quickly. Okay. Here's the Go ahead, I'm sorry.
I was just asking where's that located?
Monterey, California. Okay.
Okay.
Monterey Canyon. This is Santa Monica Bay, Los Angeles. Santa Monica Canyon, Redondo Canyon. So we got two canyons that were formed here. All right. So we have two canyons there. And these are undersea canyons. Now, these are not being cut. If there's water above it, it won't cut a canyon. It has to be dry ground to cut the canyon. So, canyon is not cut by water flowing underneath other water. Here is the Astoria Canyon, this Columbia River right off Lewis and Clark. This would be on the right would be Oregon, I believe, and then the left would be Washington State. Okay. And so here's where Lewis and Clark were. That's just where they camped, 1805, 1806. Okay, after we bought it, I think we bought the Louisiana Purchase in 1803, and then they went out to explore, and they wanted to take part of this, claim part of what was called Oregon Territory. Here's San Gabriel and Newport Canyons, and there you can see the canyons that they've got here, and this right here, A and B and C, these canyons. Again, they're undersea canyons. The Congo River comes down here and has a canyon that cuts pretty deep through there. But here's the South America, and here's the South Atlantic. Our map earlier, the undersea was the North Atlantic, and so we have that map here. We have the rivers here cutting canyons right down through here. And one of the biggest rivers in the world right here is the Amazon. And of course, we have a canyon cut down through here as well with it. So there are canyons being cut. Not much canyons on the west coast, on the west coast of South America, because it drops off so quickly. It just drops off to deep water pretty quickly. Right? So you can see some more canyons down in here, way down in here. I think this was dry ground at one time, and the water has been rising since the flood. There's your Congo Canyon. That thing, Congo River is a big river. And let's see here. The river is a large river, and it's got a pretty deep canyon going out quite some distance. Okay. Here is Pribilof Islands. This is the Bering Sea up here. This is Western Alaska, and this is Russia over here. And this is pretty shallow. We've already laid out how this was dry ground, and the animals moved across it, and the water was began to rise. There's two reasons the water rose. Ice was melting, and there were fluvial lakes on the land, and these lakes were lakes left by the flood, and some of them began to dry up, and the rainfall went down into the ocean, and some of them actually had breached what was containing them and created canyons. I believe the Grand Canyon was formed by such a thing. We'll come back to those, and I'll try to add a whole chapter to the book on those. Here are your Pribilof Islands, and this is the islands going out, the Aleutian Islands right out through here, and they go almost to Russia. Okay. That's part of Alaska. All right. Go to this link here and get the ocean floor maps and find them. And so this is a link, and you can just type it in and find it. Canyons on the seafloor have constituted for many years one of the most puzzling. This is Limbaugh and Shepard. That's not the Limbaugh radio announcer. It's another Limbaugh. Canyons on the seafloor have constituted for many years one of the most puzzling features of the face of the earth. Many of these valleys have been cut back into the continental shelf and extend virtually to the coast. Where best known, they have the characteristic river-cut canyons such as are found in mountain ranges or on escarpments of the margins of plateaus. In other words, they look just like they were cut like canyons in dry ground. Thus, most of them have rocky walls and are narrow and roughly V-shaped. Their floors slope outward almost continuously toward the ocean basin. They have many tributaries entering into the sides of the common stream pattern, just like you'd expect if it was on dry ground. Interesting. My point here is, I want to summarize it, and I thought I would get more material in here, but the atheists have difficulty in explaining submarine canyons. I think they have a great difficulty. The way they formed and the way they are shaped and the tributaries running into them and the fact that they're cut very deeply, that just doesn't fit water flowing on top of water. Water flowing underwater doesn't cut a canyon like that. These submarine canyons, additional evidence of the flood that follows Fox's flood model that I want to develop, that I've been developing, that I've set forth in my book in this series of lectures, explain these canyons and ice caps as well, Greenland and Antarctica. Now, do you have any questions? This concludes our lesson for today. Let me get out of it.